easier. Okay, so this will be review. So this is not new material, but it's good to see it again because some of you have not had math for a year plus. So it's good to see again. Talking about ordered pairs, graphing, distance formula, midpoint formula, and then lastly solving equations with two variables. All right, so just a quick warm-up refresher. The point -1, 3 lies in which quadrants? So -1, 3 would be right about here. What quadrant is that? So this is actually the first, this is the second, this is the third.
Why does math do that? Why is that the way it is? That's ridiculous.
It's just the way it is, okay? All right, so this lies in the second coordinate, or second quadrant. So the point 4, 0 lies on the graph of the equation y equals 3x minus 6. What would that y coordinate be? 6. Okay, because it's saying the x value is 4. So 3 times 4 is 12. Minus 6 gives us a y coordinate of 6. Any point that lies on the x-axis has a y coordinate of what? 0. Okay, because if I'm on the x-axis, I have not went up or down at all. So any point on the x-axis has a y-coordinate of 0. The y-intercept of the graph, y equals -2x plus 6. 6. Okay, this right here, and it's positive 6. This gives us the y-intercept where it's crossing, right there. Y-intercept where it's intersecting. Okay, and then number 5, the distance from the origin. Okay, so if we have coordinate axis and we have the point -3, 4. So I go over -3, go up 4. What is that distance? What about if I made this into a triangle? How does that help us? And specifically a right triangle. Okay, Pythagorean theorem, which remember Pythagorean theorem is x squared plus y squared equals z squared. Okay, we're trying to find this z distance. What is the base? What's my horizontal distance on this triangle? 3. And my vertical distance would be 4. So I'd have 3 squared plus 4 squared equals z squared. So if I wanted z, that would be the square root of 3 squared plus 4 squared. What's 3 squared? What's 4 squared? What's the sum? What's the square root? So z, the distance is 5 units. And that's a common right triangle is a 3, 4, 5 triangle. Okay, so this is finding distance with Pythagorean theorem. We're going to talk about using the distance formula, which is simply Pythagorean theorem, but written out as 3. We wouldn't write it as 3. We'd say from 3 minus 0 to get that length. And then the y, we'd say 4 minus 0 to get that length. And so if we weren't working from the origin, we could have it somewhere up in space, and we could still figure out what that distance would be. Okay. So, distance formula. If we had, like I said, 2 points in space, I'm going to say this is my point P and this is my point R. So now, if I want to find the distance, if I'm just looking horizontally, if this was point, I'll put in our coordinates. So P was x sub 1, y sub 1. R was x sub 2, y sub 2. That means I was here at some x sub 1, and I went over here to some x sub 2. To find that distance between the two, I would simply take x minus 2, or I'm sorry, x sub 2 minus x sub 1. So we did it when we did it with that 3, but it was because it was 0, it was 3 minus 0. We don't have to worry about anything. And then if I wanted to find this vertical height, for the vertical height then, I'm going to take y sub 2 minus y sub 1. Because this is here at y sub 1. This is here at y sub 2. That's going to give me this distance here. I'll say d is what I want to find for distance. And so distance would become, using Pythagorean theorem, square root of x squared minus 1 plus y squared minus 1. That's where the distance formula comes from. It is just the Pythagorean theorem. Okay, but now we don't know coordinates. We're just doing them abstract as x sub 2, x sub 1, y sub 2, y sub 1. So that is our distance formula. Oh, and I didn't do them squared. Missed that. So each segment squared to be able to come up with distance formula. Okay, so you'll have some MathXL problems. They'll say, okay, what's the distance between these points in space, meaning in our coordinate plane somewhere. So if we're not working from the origin, we can still do it. When it's from the origin, it's easy enough. We can just make our triangle and figure it out from there. Okay, midpoints now. Oh, sorry, go ahead. Yep. Yep, that's what I want you to do. Stop me if I go too fast. Okay, midpoint formula. So now, given 2 points again, P and Q. So if we had, so if we had some coordinate axis, and I had some point P, and then some other point Q, and P is at x sub 1 and up y sub 1. Q is x sub 2 and up y sub 2. If I want to find some midpoint M between these two, and I want to find specifically what the coordinates of that midpoint would be. Well, I know the whole distance horizontally, this whole distance across is x sub 1 plus x sub 2. Okay, that whole distance from there is x sub 1 plus x sub 2. Well, I want to split that right in half. And so I'm going to divide that by 2. And then if I want to look at it vertically, I'm going to have some y sub 2 plus y sub 1, but I want to go halfway, so I'm going to divide that by 2. So the coordinates of my midpoint M will be x sub 2 plus x sub 1 all over 2, or x sub 1 plus, it doesn't matter. You're adding together 5 plus 2 is the same as 2 plus 5. And then y sub 2 plus y sub 1 all over 2. Those will be the coordinates of the midpoints. So midpoint formula gives you a new point. Distance formula actually tells you the distance between them. So it's in feet, miles, whatever. Okay. All right. Now equations with two variables. So I say, is the point 1 comma 2, so this is not an interval, this is actually a coordinate point, 1 comma 2, a solution to 2x minus y equaling 0. So is that a point in there? Mason, how can we check to see if that's a point? Or how do we know if it's a point? Okay, so 2 times 1 minus 2. Mason, what's 2 times 1 minus 2? Perfect. So is 1 comma 2 a solution? Okay, simple enough. Okay, we can test them out. Another example, I could say, okay, find 3 ordered pairs that are a solution to this equation. So y equals 4x minus 1. I want to come up with 3 ordered pairs that would be a solution. There's a lot of ordered pairs, but let's pick 3 that we know for sure. So we could do a quick 2-column chart, x comma y, and I can pick any x value that I want. Charlie, give me an x value. What? 4. Okay. Charlie, what's 4 times 4 minus 1? 15. Okay. Give me another one. Charlie. You can write it. Dayton, give me another number. 0. Dayton, what's 4 times 0 minus 1?
Wait, no.
There we go. There we go. See, there's a reason we do these. Okay. Alyssa, give me another value. Give me a value for x. -1. Okay. Alyssa, what's 4 times -1 minus 4? Or 4 times -1 minus 1? Perfect. So we have 3 points. So 4 comma 15, 0 comma -1, -1 comma -5. Okay, let's do it again. But now I have an equation set up. X equals square root y minus 1. Same thing though, I can make an XY chart. It's a quick 2-column chart. Gabe, what would be my input on this? Would I choose an X value or a Y value? Okay, so give me a Y. Any number that you're going to do the math for. 5. Okay, so Y is 5. Okay. Gabe, what is the square root of 5 minus 1? No, 5 minus 1. 4. So X is what? 2. Okay. All right. Simon, give me another number. 10. Okay. What's my X going to be then? 3. Ooh. Okay. Let's see. Kenzie, give me a number. -1. Okay. So -1. If I put -1 in here, what are we going to get for an x output? What's that? We can do it. So -1 minus 1 would be what? No, -1 minus 1, -2. Okay. So let's go back to our imaginary number work. What is the square root of -2? Okay. That would be I root 2. But graphically, we can't graph that. So that's an imaginary solution. And we're not talking about imaginary solutions right now. So let's just rewrite this. Let's do it as a +1. So if I was a +1, 1 minus 1 would be 0. What's the square root of 0? 0. We can do that. Okay. So 3 coordinates would be 2, 5, 3, 10, and 0, 1. So independent variable is what we're putting in. So with whatever it equals, like this equals y, so let's put in an x. This equals x, so let's put in a y. Okay, but then still our coordinates are going to be x, y. Intercepts. So we did this in the warm-up. What do we know about the y coordinate at an x-intercept? So an x-intercept simply means where it's crossing the x-axis. We know the y coordinate will be 0. And then what do we know about the x-coordinate at any y-intercept? At any y-intercept, we did not move left or right. So in this one, the x-coordinate will be 0. And why this is useful is we can use this for graphing. So if we are in some standard form, AX plus BY equals C. So that's standard form. C will be some number. If I was in this form, in standard form, sometimes we call it just cover-up method. If my x is 0, I don't have to worry about this at all. And I could simply solve for y. And that would tell me what my y-intercept is, because this would be like 5y equals 10 or something like that. So if I said x is 0, I know I'm going to get my y-intercept. And then if I set y to be 0, solve this, I'll get my x-intercept. So this idea that x-intercepts will be when y is 0, y-intercepts will be when x is 0. So we can use this for graphing. Okay, so we'd end up with 2 sets of intercepts. Maybe it looks something like there and there. There would be our line. If we know intercepts, we can put them right on the x and y axis, connect it with a line, and we've graphed. Okay, one more. Given any equation, if you're asked to graph it, your first thought that should come to mind is to make a 2-column chart. If I give you any equation, I said graph it. If you know points, you can plot points and connect them with a line. So on this one, we have x squared minus 4. So am I going to choose an x value or a y value to start out? X. Let's choose an x. That's my independent variable. Whatever I choose for x, that'll tell me y. So Kyle Powers, give me an x. 2. Okay. Kyle, what is 2 squared minus 4? 0. So I know a point is right here at 2, 0. This might be a refresher for you as well. 2 comma 0 means I go over 2 up 0. It's not up 2 over 0. So it's the x and the y. Okay. Hopper, give me an x value. Huh? So 0 minus 4. So I'll go down here to negative 4. Okay. Jackson, give me an x value. 3. 3 squared minus 4. So over 3 and up 5. So is this an accurate representation of what this graph will look like? Yes? No? Jack Parker, what other point might you choose? Okay, so give me another point, or give me another x value that we'd want to choose. What's that? Positive 4? So, okay, so if we put in 4, 4 squared is 16, 16 minus 4 is 12. So we're going to be over here at 4, then up here at 12. Okay, you're right on the... Thank you, Teddy. Give me a negative. Negative 2. Okay, without doing any math, what's that going to be? 0. Because, yeah, what Jack was saying is we found our axis of symmetry right here. It's going right along the origin. And so let's pick a negative value. And this negative 2, 0 and positive 2 zeros will be those mirror images of each other. And I also know negative 3, 5 will be a point. I also know negative, oh, I think I'm off one. Yeah. I also know that one. And so it's going to look like that. So that is a complete picture of this function. Simply giving me one side of it is not complete. But once we know a couple on one side, we can simply reflect it over that axis of symmetry, and we have a complete picture of what this function will look like. So make sure you're choosing numbers that are left of your axis of symmetry and numbers of your right, over to the right. Okay, that's it. So 2.1 is in MathXL, due tomorrow by the start of class. So I was 7 minutes long.